So today we are going to kind of finish our discussions about how to read different sine and cosine graphs, different waveform graphs. So one of the things that we've been talking about is determining whether or not a graph is sine and cosine and whether or not that amplitude is positive or negative. So let's just start by sketching the different shapes that are going to show up with it. So if we have a positive sine graph, we've covered this before, but that's going to start at 0. So at 0 degrees, we start at 0. It's going to go up to 1, come down, cross 180, hit -1, and then back up to 0 before it keeps going and repeats. Now, the negative sine graph, all we're going to do is flip that positive hill and that negative hill around. We're still going to start at 0 at 0 degrees, but now we're going to start by going down first, and then up, then back to 0. So when we're looking at graphs and we see that at 0 degrees here at my y-axis, we start at the equation's midline, we know that it's going to be a sine graph. Then we look and see, okay, does my sine hill start positive or does it start negative? If it starts positive, we got a positive sign. If it starts negative, we have a negative sign. All right, let's check out the cosine here. So if we remember our positive cosine, that's going to start at 1. We could dip below our axis or our midline and then come back up to 1 for one full cycle. So very similar to our negative sine, our negative cosine is going to follow that same shape. It's just going to flip it. So in this case, it starts at -1, trends up through our axis, and top out at 1, down through our midline, and then back to -1 before it repeats. So in this case, we look and see, okay, if at 0 degrees our graph is not starting at the midline, it's going to be a cosine graph. And then if it starts positive, sloping downwards, it's going to be positive. If it starts negative, sloping upwards, it's going to be negative. The other thing we want to start reading from our graphs is the period. So if we recall, this is going to be the peak-to-peak distance. So if you look at this image here, the distance between the hills of our graph. We can also find it by grabbing two other points that repeat. So in this case, if we wanted to look at this point here and this point here, that covers one full pathway of the wave. But let's just start by getting these definitions down or these steps down real fast for finding the period. And step 2 here, determining B coefficient through guess and check. You'll kind of see what I'm talking about as we work through some examples, but we can pretty much think our way through that to arrive at our B coefficient. So let's run through some examples here, and we're kind of continuing to build our list of things we're grabbing from each of our plots here. But example 1, the graph is on your sheet. We're going to go through, we're going to find all of the features of this graph. So let's first start with our vertical shift, that D coefficient. If we find that midline, it looks like our midline would be at 2. Actually, I'm going to color code this with red here. Our midline would be at 2. That's our line of symmetry. So if you look, we have equal parts above and below our graph. So D is equal to 2. And the equation of midline is y equals 2. So then we start to think, all right, do I have a sine or a cosine graph here? And if we go back to those 4 charts we made, we look and we see, all right, at 0 degrees, we're starting at the midline, and we're going upwards first. So in this case, we're going to have a sine graph, and that sine graph is going to be positive. Then that can help us find our amplitude. So if we sort of count from midline to one of these hills or midline to one of these valleys, either way, we get 1, 2, going up from 2, 3, 4. So 1, 2 is going to be our amplitude. And since that's a positive sine wave, we're going to leave that A as a positive 2. Now here's where it gets tricky. We haven't done this before. We're going to find the period. And this can be a little more difficult because we're starting to work with some fractions. Let's first identify two hills that we're looking at. We're looking at this peak, and this peak would be a good spot for us to pull that from. We could also use the valleys if we wanted to figure this out. However way you do it is fine. If I trace down, and I'm going to take the right peak first because we're going to subtract, I see, okay, that's 5 pi over 2. So 5 pi over 2. And we're going to subtract whatever this first peak was at. So if I trace that down, this one's at pi over 2. And we'll notice that if we do that, we're going to get 5 of something minus 1 of something is going to give us 4 pi over 2. And we could simplify that, and I know I'm running out of space here, I apologize. We can simplify that to 2 pi if we wanted to. So our period there is 2 pi. Then in terms of what b is equal to, b is going to have to be equal to 1 here. If you think that the period is equal to 2 pi over b, then in that case, b would have to be equal to 1 in order to make that period true. Now, we have all that stuff figured out. It's a big mess, but we're going to write it now in a concise, clean formula. Let's start it off with a here. So our a comes first. We have a positive 2. Then we know we have a sine graph based on what you identified earlier. My b coefficient is 1, so we're just going to leave that blank, 1x. And d is 2, so it's going to be plus 2. And that's going to be our formula there. 2 sine of x plus 2 is what gives me that graph. All right, let's try this again on a new equation. Go ahead and pause your screen, try this, and check it against mine. I'm going to go ahead and pause mine and start filling in some blanks. And then if I hit a point that I need to discuss, I'll unpause it and check it with you. So our midline here, I can see, is going to be at 2. I'm going to draw a dashed line across. So our vertical shift is d. Our equation of the midline is y equals 2, just like before. I can look and see that, hey, at 0 degrees, our graph is not starting at the midline. It's starting below the midline. So it's going to be a cosine graph. And it starts in the negative value, so it's going to be a negative cosine. So let's circle cosine, circle negative. If I measure the amplitude here, let's do it on one of these guys just so we have some clear space to look at. It looks like it moves up 1 from my midline to my peak. That also holds true if I go from my midline to a valley. And finally, period here, I'm going to take these first two. So this peak here, if I trace down, I have 3 pi over 2 minus this peak, which is pi over 2. And so in this case, I have 3 of something minus 1 of that thing. I have 2 pi over 2, which makes my period equal to pi. And in that case, if we reason through, all right, b, period is going to have to be equal to 2 pi over b, right? And you don't have to write that thing on the side if you don't have to. So in that case, b is going to have to be equal to 2 in order to get that to cancel out with my 2 up top. And that'll leave us with a formula of, we don't have to write that a because it's a 1 out in front. I'll write it at first just so we can see it. Formula will be negative 1. Let me go back here. I just caught that. Should be a negative 1 because we have that negative amplitude. Cosine 2x plus 2. That will be our formula there. All right, we got 2 more examples. Please continuing to pause, try this on your own, check and see if you're right. The first thing we do is find that midline. In this case, it's on our axis. So the midline, D, or the vertical shift, D, is at 0. That equation of the midline, which I'm running out of space here, I'll write as y equals 0 right here. We look and see our graph at 0 starts not on our midline, it starts above, so this is a cosine graph. And it looks like it takes the shape of that positive cosine graph where it starts positive, goes negative. So if we then measure the amplitude, I'm going to jot it down over here. It looks like we can count 1, 2, 3 spots to find my amplitude. So since we have a positive graph and the A is 3, then our amplitude is just going to be equal to 3 there. And if we look, we can see, all right, looks like I have a peak here at 2 pi. And I have another peak at 0. So my period is simply going to be equal to 2 pi, which means, we saw that earlier, B is going to have to be equal to 1 in order to make that formula hold true. Then if we want to go ahead and write all this in, we have an amplitude of 3. Our graph is a cosine graph, so 3 cosine. B is equal to 1 here. B is equal to 1 here, so if we want to write it in there, that's fine. Otherwise, we can leave it blank and just put the x. And D here is equal to 0, so if we wanted to write plus 0 at the end, you could. But you can also go ahead and leave that portion blank as well, because adding 0 to something doesn't really change it. All right, last example. This one's going to get a little tricky with the period, but the rest of the stuff should be pretty straightforward. We're going to find that midline. It looks like it's at 1 here. So the D value is 1. Our equation of the midline, y equals 1. Then we look and we see, all right, we are starting on the midline point when we're at 0 degrees or 0 radians. So this is going to be a sine graph. It does start trending downwards though, so it's going to be negative. And if we measure our amplitude from the midline to one of our peaks, it looks like we get a value of 2. So since this is a negative graph, it's going to be an amplitude of negative 2. So there's a couple different ways to think about the period here. You'll notice that it's going to be a little more difficult as we work through. If you trace one of our peaks here down to our axis, you'll notice that we don't cleanly line up with our kind of tick marks, so it's difficult to read. So in that case, let me erase this real fast. In that case, I'm going to look at 2 different points that do cleanly line up with my tick marks, and I'm going to pull those in order for me to kind of calculate the period. So if we look here, we have a point on our graph that lines up with 2 pi. It also conveniently hits our midline. And we also, if I trace that back 1 full rotation, so I hit that positive hill, I hit that negative hill, I have a point right here that hits that midline again after 1 full rotation that cleanly lines up with pi. So we can then calculate the period that way. We have 2 pi minus pi, and that's going to just leave us with pi. So in that case, in order to make our 2 pi over b period, or 2 pi over b equal to pi, we would need a b value of 2 in order to make that work. If you wanted to, you could also pull these peaks and estimate kind of, hey, what fraction would I need to hit? If you were looking at this one here, it would be 3 pi over 4. And if you were looking at this peak here, it would be 7 pi over 4. But either way, you would end up getting the same answer for your period. So our formula, if we write that, we're going to have the amplitude of negative 2. This is going to be a sine graph, as you guys pulled. It's going to be 2x with that b coefficient. And finally, we're going to add 1 for our shift.